So for this question, the first thing we're going to do is we are going to plug in and see what we're dealing with. So we have cosine of pi over 2 over pi over 2 minus pi over 2. Now, if you're up here at pi over 2, your cosine value will be 0. So your numerator is 0, denominator is 0. So you do, in fact, have a 0 over 0 situation. Now, in test 1, what we talked about is how we would try to factor, cancel, and plug in. The issue with this particular question is it's kind of like, well, how am I going to factor cosine x? So this method is not abundantly clear as far as how we are going to implement it. So in this particular case, L'Hopital's rule, which I'm going to abbreviate with LH, is the easiest thing to do, and in fact, the best way to go. So what we're going to do is we're going to take the derivative of each of the numerator and the denominator. So remember, with cosine, you got to be super careful about the sign for sine and cosine. So that's where we use that is DC negative. So differentiating cosine does give us a negative. So we'll have negative sine x over, now when I take the derivative of the denominator, pi over 2 goes to 0, because remember, derivatives you drop, negative x becomes negative 1. So I take the derivative of the top, I take the derivative of the bottom, and then I plug in and hope and pray that that gives us a finite number. So when I plug in, I get negative sine of pi over 2 over negative 1. Now again, if you look at pi over 2 on the unit circle, your sine value is 1. So this is going to give us negative 1 over negative 1, which gives us a finite number. So by L'Hopital's rule, we are getting that this limit is equal to 1.